Hello and welcome to Lesson 11. This is a little bit more about programming. We're going to talk about classes, which is a computer concept that is important for designing any kind of activity on a computer, and objects, which is a concept that's very important for implementation and allowing your implementation to be shared easily by other people. Be sure to download the software from the website, and the example that we're going to use in this lesson is Techno Fire, or as close to something that looks like fire as we can create. As I mentioned a minute ago, a class is an abstract concept used to model a problem solution. Basically, a class is anything that makes sense to a human, so it could be a dog, a watch, a shoe, or fire. A class is composed of properties like color, location, texture, hair, fingernails, whatever, actions, drawing, erasing, moving, rotating, barking, singing, dancing, fighting, whatever. Rules, like if the color is green, then the object cannot be attacked, and if the color is red, then the object can attack anything. Relationships, which would be like fingers are related to hands. If you have a hand, then it has fingers. And state. State we talked about before is the object is at rest, the object is sleeping, the object is walking, the object is fighting, and the states have different effects on the properties, actions, rules, and relationships. An object is the implementation of a class model in whatever programming system you're working with, and the parts of the programming system that we can manipulate are the data structures, the methods, which would be the subroutines and functions, and the statements in the language. They would be combined to create an object such as the fire object. In implementing a fire object, we're going to use a time sequence of textures to simulate a moving flame, and then we're going to vary the brightness of a light over the texture pictures, if you will, to create a flicker effect that you would get with a physical flame. In bottom-up programming, which we're going to use for this particular example, you first implement a quick and dirty solution for one flame, and then you try to use what you've learned to implement an object that could be replicated to give you 2, 3, 4, 5, 100, or as many different flames as you want. The quick and dirty program is OGL/fire1. If you examine the text, you'll see that the data structure consists of a count of the number of textures, an ftext field, which is going to have 32 elements, which are the texture indices, a firelight field, which is going to have 32 light values, and the flames field, which is used to step 0, 1, 2, 3, 4, 5, which basically is going to select a different texture and a different light. The implementation, as you can see, basically sets a diffuse light to the intensity selected, then binds a texture and lays it on top of just a unit square. And the texture basically covers the square so that you don't really see the edges, and then the count is incremented mod 32. Based on our experience with the quick and dirty implementation, we're pretty much going to have the same properties in the class, but we're going to add a location property so that we could place flames at different XYZ coordinates in whatever video that we're creating. Once we have the abstract design of the data structures, we look at the methods, which basically would be a load method that would initialize anything that has the same value across all the instances of the class, like the texture values, and then an init method which would initialize each individual flame, for example its location, and a draw method which would be used to draw each individual flame. Next we implement the fire object, which is going to be a property list with data values for the abstract design elements or the properties and code strips for the methods. So we have a load, an init, and a draw code strip. If you look at the implementation or the initialization of the objects, we have a load call, which is done once. We create 3 objects with an array of 3 elements, and then we go through a loop, call init on each element, and then we set its x coordinate to 2, 1, 0, so it's just laid out across the x-axis. Then to draw the element, we basically copy the code from our quick and dirty implementation, but remember to use the this method to refer to the instance of the class as in lesson 10. And then drawing the fire objects is very simple. You just iterate over the array length and you call the draw method for each of the objects, and it draws the fire at the appropriate location, as was illustrated in the 3-flame video back at the beginning of this lesson. We also can take the code and implement a fire command. Basically, an object is an entity that makes programming easier by reusing other people's code in very flexible ways. A command does the same thing at the command interpreter level, and an icon, as you would see in a Windows system, is intended to be the same thing at the window level. This is an example of the gradient texture and the fire command. You can look at fire.txt and see that the code is basically what we've already used, and you put the two together and you get quite a nice title slide.